Hello, ladies and gentlemen. We're going to tackle a new concept today, or not a new concept, a new theorem though. And this is called the exterior angles theorem. Still has to do with triangles, and it still has to do with creating an equal sign to find unknown values. It's just a new theorem. It's just a new rule that has been tested and verified to be trustworthy and true. Now, before we dive in, let's first break down what these means, exterior angles and interior angles. So the interior of a triangle is the inside, interior, inside. So this would be considered the interior of a triangle. And the exterior of a triangle would be everything that's on the outside, exterior. So interior angles are just the angles that are on the inside. Those are called interior angles. And exterior angles are those that are on the outside. So C is an exterior angle, and B and A are interior angles. Pretty straightforward, right? Okay. So what is the exterior angles theorem? Well, the exterior angles theorem states that every exterior angle is equal to the sum of its opposite interior angles. So in other words, angle C, this exterior angle, is equal to the sum of angle A plus angle B. And there you have it. We have an equal sign and things that we can plug our variables into. Lovely, isn't it? So simple. Now I want you to notice that we're still using the same letters as the last theorem. But notice that the letters don't mean the same thing. In the last theorem, angle C was an interior angle. In this theorem, angle C is an exterior angle. What does this mean, Mr. Grapp? It means that letters aren't permanently fixed to one thing. It means in math, we're allowed to use letters interchangeably from theorem to theorem. So it's less important for you to know the theorem by the letters and more to know the theorem by its meaning, by its concept. Exterior angles, this could be a star for all we care. Star is equal to box plus happy face. They're just symbols. So it's more important not to know that C, A, and B are the letters we use in the theorem, but more important to know it as C is the exterior angle is equal to the sum of the opposite interior angles. Second thing you want to notice is that this third angle here, let's call it angle D, is completely ignored. It's not part of the theorem. So don't use it. Don't use it when you're trying to find the theorem, all right? If you're trying to use the theorem, ignore it. Opposite interior means the ones that are farthest away from that exterior angle. Okay, let's dive in. Example 1. First step, we're going to write the exterior angle theorem. What is that again, Mr. Grapp? That is angle C is equal to angle A plus angle B. All right. Now this one is already chosen for us. We know which one is C. That one will always be C. The one on the outside is always going to be C. But which one's angle B and angle A? That one we still have choice. We can make this A and that B. It doesn't really matter. Okay. Step 2. Let's plug in our angles. Plug in the angles. So angle C, x plus 24, is equal to A plus B, 55 plus 75. And then step 3 will be to simplify and solve. Simplify and solve. So let's do that. Let's simplify. Anything I can combine on the left side? No, there's nothing I can combine on the left side. So that's going to stay x plus 24. I can combine the 55 and the 75, though. 55 and 75, that's 110? No, 130. There's a grab having a brain fart here. Let's use the calculator. 55 plus 75, 130. There we go. All right. I'm going to move that 24 to the other side. So x is equal to 130 minus 24. And that'll get me my final answer. X equals 106. Cool. There you have it. Same as the last theorem, though. Like the same steps. Use the theorem, plug in the angles, simplify and solve. Let's do it over here. Angle C is equal to angle A plus angle B. Again, angle C is picked out for us, so we don't have any say in that matter. But we can choose between which one we want for A and B. But again, it really doesn't matter. All right, C. 3x minus 15 is equal to 37 plus 113. All right, let's see if we can combine anything. There's nothing we can combine on the left side, so I'm just going to keep that as 3x minus 15. But I can combine these two numbers. 37 and 113 is 150. All right. Let's move up a little bit higher here. We're running out of room, so let's just squeeze that up a little bit higher. I'm going to move that 15 to the other side. Oop. Get a marker out. 3x is equal to 150. And be careful here. Plus 15. Now, if you put minus 15 or thought minus 15, let's remember. Opposite sign when it moves to the opposite side. Right? It was minus 15. When I moved it over, now it's a plus 15. So be careful, because that'll trip you up if you're not careful now. 3x equals 165. And I'm not quite done yet. I still have a 3 here, but we know how to get rid of a coefficient. We just divide by it. Divide by 3. And let's move this a little bit higher, actually. Let's do the same thing we did with the last day on the last example. We'll move this over here. And we'll move these guys closer. Cool. Slice and dice. X equals 55. Boom. There you have it. All right. That's the exterior angles theorem, guys. C equals A plus B. Plug in your angles. Simplify and solve. C equals A plus B. Plug in our angles. Simplify and solve. Be careful when you're moving your constants from one side to the other. Make sure that if you move it from the opposite side, you're using the opposite sign. Okay. My challenge to you is to take what we've learned here and attempt the next 4 problems. In the next video, I will go over each. I'll see you there.